Hey, the average Joe here. Hey, today we're going to look at a lab project and look at changing the pipe sizes and the material types and just kind of go over the pipe sizing again. Here on my screen, you're going to see four air handlers and then the airflow diagrams and then the hydronic chilled water and hot water schematics and then a little diagram showing the mechanical room. So let me zoom in here, get this a little bit closer. Now, when we create a rooftop unit, these are rooftop units, just because they were obviously on the roof and not in the building. Um, you'll see here we show the rooftop unit and the coils and fans and filters and dampers, and then always the airflow diagram, and then the exhaust systems associated with this lab offices and some of the spaces there. This next one was general building, so it has some general exhaust. And then the one over here, you'll see it's 100% makeup, signified by all the blue lines going to purple's kind of supply. And then it had lots of exhaust going on the big building there, test building. And then another 100% outside air unit here going to different labs and engine rooms and storages and shipping areas, all with exhaust fans and obviously stacks. The stacks get the contaminated fumes up and away from the building. And then down below, the hot water and chilled water schematics. So let me click on a pipe here. We'll go down the mechanical room of the heating schematic. You'll see all the pipe sizes are 2.5 inches in that room. You can kind of double left click on a pipe. Now you can put in length, obviously, to get better dimensions on head. You can do that individually on each pipe, or I usually do it just on the right before and after the pump and take the longest length, going out to the furthest device. In this case, it'd be going out that heat exchanger and coming back. And then part along with that key data, obviously, we have a maximum velocity, which you can change, and the maximum unit head loss, which is typically 3.3, 4.0, right, in feet per 100. And then obviously, as soon as that 2.2 feet gets up to 3, what happens? Well, this diameter is going to go to 2.5 inches. And if this is checked, that means the user's actually selected that. I'm going to hit calculate here. And he wanted 2.5 inches for some reason. We'll see if the pipe size based on these parameters is either higher or lower after calculating there. And then the materials can be changed right up here in the construction of the pipe there. This is taking a little bit longer, a little complicated project here. And I'm on a laptop here, a little slower computer. So it was a 2.5 inch pipe was the size, so I don't know why that was checked. Now in the construction, that is where you can change to a different pipe. You'll see right now it's standard steel weight. So let's come in here and let's just say everything in the mechanical room. We'll just highlight all those and then click on something. And now I can go in under pipe, hydronic, that's going to get all those. There's the different sizes of pipes that might be in there. So there are some that are different sizes. But I'm going to come in there and I could change them all. Same mechanical room, you all want it to be, standard steel weight, which is good, right? Or maybe you want it extra strong. So now all those pipes would be extra strong. And then maybe out in the system, maybe after you go to smaller sizes, you want to do some type of a, PEX piping or some just other type of piping that's, out in the system on a smaller scale. And so you can go and highlight all those out in the system or highlight a certain pipe size and change those as well on that. I'm going to also click on another pipe here. So sometimes if we don't have your construction material pipe in here, I was just asked last week, what about HDPE piping? That's real similar to PEX as far as the roughness factor goes, but it might be a little bit different diameter. So in that case, when you're on a pipe under selection, you can come in here. There's the diameter that we selected. If the inside diameter is a little bit different because it's HBT, DP pipe, maybe it's 2.1 hit a 1 there, on the inside diameter, right? Because the inside diameter is what the calculation is going to be based on, and not necessarily just a 2.5-inch pipe, right? That's the outside diameter. So that's a nice thing about doing the calculations in software. It's always looking at the type of pipe and roughness factor, and then that inside diameter. Sometimes people change from a copper pipe to or a steel pipe to like a PEX pipe, and they think their head might go down. But in many cases, copper pipe has a very thin wall, and so that inside diameter on a 2-inch is bigger than a 2-inch PEX piping that has a thicker wall and has less less free area on the inside. So that's basically how you can change all the pipe sizes to different types, or the inside diameter to something else. And then you can come out here and highlight, all the rest of the pipes on the project, go in, change them to PEX if that's what you wanted. And then the schedules will all relate that, based on the project. Anyway, hope this has been helpful in, being able to change that inside diameter to match maybe the pipe that you're trying to model, as well as, changing the, looking at the head on the system. So, hey, thanks for watching. Appreciate it.